Okay, so I'm just gonna give it a demonstration of a dual slope integrator, tentative design. I have an input voltage of 10 volts. Okay, this is a voltmeter. Okay, so 10 volts is the initial input. I set the fixed count to about 100. So when it reaches 100, it goes to vref and does a second integration. Let me just show this graphically. So the output of the integrator is as follows. So the initial integration, the first integration has already been done. Now let's go into the second integration. So that means it's switched to vref. Vref is this guy here. So now it's at minus 15 and it's going to 0. And when it reaches 0, the final count, we should be able to ascertain what the unknown voltage is because this is a voltmeter. So it's going to keep counting until a time comes when it reaches about 0. I think above this point it will become irrelevant. Of course, I also put an inverter to sort of invert and show how this sort of thing is working. So I put an inverter here, right, doing the opposite of what's on the other end. See that? And okay, finally we have a final count of 166. So now we have to compute what the voltage is. So to compute the voltage, my bad, what's going on there? To compute the voltage, I'll have to use this formula. I have to find T2. So I have to understand what the F clock is. F clock is 125 Hertz in this particular case. Let's just take a look here. It's 125 Hertz. So we go do a little substitution action. Let's demonstrate this. Okay, we just do a little substitution action. 166 is the final count. The count at which vref will be triggered is 100. So T2 is 0.25 seconds. From here, we can therefore determine what Vin is. So Vin is about 9.9 volts. Now, of course, we know what Vin is. It's 10 volts, so it's off by 0.1 volts. Consequently, this constitutes an error of about 1%. So it's reasonably accurate. I'm thinking this error could be due to non-ideal effects of the components used. Yeah, I think there could be some loss or something. And yeah, and to find Vn, we have to use this equation. This equation here, vref T2 over T1, and then ultimately, then with x here, and then ultimately you just do some substitution. This is vref minus 15. We ascertained what T2 is. We know that T1 is fixed at 0.8 is how it was where I fixed T1, right, which gives a count of 100 in this particular case, given the clock frequency. So this works.